So today we're going to finish up the prerequisite chapter. We're doing still P5, but it's part D. And today we are going to still work with rational expressions, but today they're going to be complex fractions. So what we're going to see are fractions inside fractions. So we would have two options on how we can solve these or simplify these. We're not solving, we're simplifying. So option one is to find the LCD of each fraction, then multiply each term by that LCD, then simplify. And then option two is to find the LCD of the numerator and the denominator separately, then state, change, flip. And that's the option of how I'm going to show you. So let's go ahead. So that's basically the idea that we're going to do here. And we're going to do 10 examples. So we're going to start out nice and simple. So again, this is a fraction in a fraction. So I have my fraction bar here. This is the main fraction bar. So I have this fraction on top of this fraction. Now, there's nothing to add or subtract in either the numerator or the denominator. So again, remember your fraction bar here. This is the division sign. So I'm going to go ahead and change this problem so it's a division problem. So I'm going to be doing 1 over x divided by 1 over x squared. Now I'm going to do my stay, change, flip. So this one stays. This one I'm going to change to multiplication, and then I'm going to flip this fraction upside down. And now I'm going to look for things to simplify. Remember, when we simplify, we can only do top to bottom or side to side. I mean, not side to side, diagonally. So I could actually simplify diagonally. I can change this x. X divided by x is 1. X squared divided by x is just x to the first. And now I'm going to multiply what remains. So in my numerator, it's 1 times x. And in the denominator, 1 times 1. So my final answer here is x. For number 2, again, we don't have anything that we need to add or subtract here in the numerator or the denominator. So again, I'm just going to turn it into a division problem. So I'm dividing the numerator by the denominator. Oops, I made my fraction bar in the wrong spot. Right here. Divided by 1 over x squared minus 4. I'm going to do my stay, change, flip. Stay is the first fraction, change to multiplication, flip upside down. Now we have a multiplication problem. Remember, you need to factor anything that can be factored because we need to look for things to simplify. I can factor my x squared minus 4. This is the difference of two squares. So this will factor into x minus 2 and x plus 2. So now let me rewrite it so it's nice and clear for you. So 1 over x minus 2 times the factored difference of two squares. And now I look for things to simplify. So I can simplify my x minus 2's. They become 1's. And now I multiply what remains. So in the numerator, it's 1 times x plus 2. And in the denominator, 1 times 1. And again, it simplifies to x plus 2. For number 3, still the same thing, nothing to add or subtract. I'm just going to turn it into a division problem, flip it, and then factor and simplify. So 1, here's my main fraction bar. So 1 over x squared minus 9 divided by 1 over x minus 3. Stay, change, flip. Now I need to factor this one. Becomes x plus 3. X minus 3. So So let me rewrite it so it's nice and clear. So it now becomes 1 over x plus 3, x minus 3, times x minus 3 over 1. Look for things to simplify. The only thing that simplifies are the x minus 3's. And now I'll multiply what remains. 1 over x plus 3. And we're done. Now, next one. This is where we're actually going to be doing two subtraction problems. Once we simplify the numerator separately, the denominator separately, then I'll turn it into a division problem, then I'll do my state change flip, and then I'll multiply. Let's try number 4. So what I need to do is think about doing this problem separately. So I'm going to take 2 over x minus, and I could put 3 over 1. I need to find a common denominator. It's going to be an x. The first fraction is good. The second fraction is missing the x. So I'm going to multiply the top and the bottom by x. So this now becomes 3x. I now add my numerator, and it becomes 2 minus 3x. I cannot add the 2 or subtract the 2 and the 3 because the 2 doesn't have an x, so I just leave it side by side. So now my new numerator is 2 minus 3x over x. Main fraction bar here. Now I need to do the same thing to the denominator. I need to add 1 over x, or 1 over 1, minus 1 over x minus 1. Now I could do a key flip change here first. Now my common denominator is going to be x minus 1. This one is good, the second fraction, but the first fraction is missing, the x minus 1. And if you think about it, you were trying to turn a whole number 1 into a fraction with the same denominator. So remember, you just put the same thing over the same thing. Now I can go back and add up my numerators. So I'm doing x minus 1 minus 1, and it gives me x minus 2. The bottom stays the same. So now this is my new denominator after I've simplified and subtracted. Now I can do the division. So I'm now doing, and maybe I'm going to do this all the way over to the side. I'm doing the numerator. I'm divided by the denominator. I'm going to do my state change flip. Stay, change the multiplication, flip upside down. Now I look for things to simplify. However, and I think I forgot something, this should be an x. Nothing simplifies. So now I'm just going to multiply straight across. So it's 2 minus 3x, x minus 1 over x times x minus 2. And we're done. Now, in the homework tonight, it's a worksheet, and for those of you who are going to look at the second page where the solutions are posted, the solutions, and it's only the answers, it does not have all this work. So when you're doing the homework tonight, if you have no work and you just put the answer that's on the second page of the worksheet, you're going to get a 0 for homework. These problems are going to involve a lot of work. No work, no credit. Now, the homework, the answers that are there, they've actually foiled the top and distributed the bottom. I'm okay with you leaving it like this. So when you go to check your answers in the homework, if this were a question in the homework, their answer would be the top foiled. So if I go ahead and just do that to show you that there are other options here. So if I FOIL the top, I get -2 minus 3x squared plus 3x. And then if I distribute the bottom, then if I combine my like terms here, the way that you're going to see the answer written in tonight's homework, if this were the question, and actually I could put it in standard form. Let me do the -3x squared plus 5x minus 2 over x squared minus 2x. So this is how you're going to see the answer. They're taking this, foiling and distributing. You can leave it unfoiled and undistributed, but be aware, if this were a question on a PSAT or an SAT, realize that both of these are good answers. Everybody with me on that? All right, so just be aware that, and I can just show you real quick, number 4. All right, everybody good on 3 and 4? Let's go to 5 and 6. So again, our main fraction bar here is right here. I only need to worry about subtracting the denominator. The numerator is just the x plus 5 over 1. And it's going to be divided by whatever we get now. So let me go ahead, and my common denominator here is going to be 5. This one's good. This one's missing a 5. So this is going to become 25 over 5. So now my new denominator is x squared minus 25 over 5. So now I do a keep flip change. So x plus 5 over 1 times 5 over x squared minus 25. I now need to factor this difference of two squares. It becomes x plus 5, x minus 5. Let me rewrite it now. And now I look for things to simplify. The x plus 5's simplify. And now I multiply what is left over. So 1 times 5 is 5, and 1 times x minus 5 is x minus 5. So that's number 5. The next one, nothing to add or subtract. So let me go ahead and set up my division problem. I have x squared minus 1 over x divided by 1 minus x minus 1 squared over x. I'm going to set it up as a keep flip change. X squared minus 1 over x times, flip it upside down. I'm going to rewrite the square as x minus 1, x minus 1. Now I also need to factor this numerator, and it becomes x plus 1, x minus 1. It's the difference of two squares. So now my problem, I'm going to simplify. X plus 1, x minus 1 over x times x over x minus 1, x minus 1. I look for things to simplify. The x's can simplify and become 1's. And then I can also simplify my x minus 1 and an x minus 1. And now I'm going to multiply what remains. And what remains in the numerator is just x plus 1. And in the denominator, x minus 1. I cannot simplify anything else. Okay, many of you on the test next week are going to be tempted to say, this cancels, and I'm left with -1, and you're going to get it wrong. Remember, in order to simplify here, you're looking for an exact match here. These are attached. All right, here we go. All four operations in one problem. I'm going to be subtracting the top, adding the bottom, then turning it into a division problem, then doing my state change flip and multiplying. So let's go ahead and take care of our numerator. So my numerator, I'm doing 6 over 1 minus 5 over x. I need to find a common denominator. It's going to be x. The second fraction is good. My first fraction is missing the times by x. So the new numerator becomes 6x. I'm going to add my numerator, 6x minus 5 over x. So the simplified numerator is 6x minus 5 over x. I now need to do the same thing to the denominator. I'm doing 1 over 1 plus 5 over x. I need to find a common denominator. It's going to be x. Second fraction is good. First fraction, again, is missing the x. Add the numerator. And that's your new fraction for the denominator. Now I turn it into a division problem. So I'm doing 6x minus 5 over x divided by x plus 5 over x. State change flip. And look for things to simplify. The only thing that simplifies here are the x's. And now I multiply what remains. Final answer, 6x minus 5 over x plus 5. Nothing simplifies. Again, you're looking for an exact match to cancel. Try number 7, or was that 7? Now 8. All right, 8, oh boy, this looks kind of complicated. This time we're doing 2 addition problems, then dividing, then multiplying. So again, I need to find a common denominator for my numerator, and it's actually going to be both. Remember, I can't just add a plus 1 to the second fraction. So my new numerator is going to be a times a plus 1. And then here, this one's missing an a. This one's missing the a plus 1. So my new numerator on the first one, a times a is a squared. And on the second one, it's just the a plus 1. Now, do not look for things to simplify or cancel when you're adding. We need to add that yellow numerator. So my new numerator becomes a squared plus a plus 1, and it's all over the a times the a plus 1. Now I need to add the denominator. And again, we got the main fraction bar here still. So now my common denominator, same thing, is going to be the a times the a plus 1. My first fraction is missing the a plus 1. So 1 times a plus 1 is just a plus 1. My second fraction is missing the a. I add the numerators to a plus 1 over a times a plus 1. All right, so now this is my problem here. And again, this fraction bar means division. So I'm doing a squared plus a plus 1 over a times a plus 1 divided by 2a plus 1 over a times a plus 1. I'm going to do my keep flip change. So it's a squared plus a plus 1 over a times a plus 1. Change the multiplication, flip upside down, and now I'll look for things if I can factor. The only one that I need to try to even think about is this one. However, there are no factors of 1 that give me 1, so that trinomial stays. So now all I do is look for things to simplify. So I can simplify the a times the a plus 1. I got an exact replica up at the top. And now I multiply what remains, which is just the a squared plus a plus 1 over 2a plus 1.
You wouldn't be able to factor the a plus 1 with the 2a plus 1?
No.
Like taking out 1a?
No, because it's attached. So again, I'm looking for an exact match. Now, if this trinomial up top here would have been able to be factored to a binomial that canceled, then absolutely. But I can't factor that trinomial.
I have a question.
Yes.
So say that the ones that you did cancel out, if the thing in the parentheses was different, could you cancel out the a's in front of it?
Absolutely. So maybe it would be better than if I do show you that I'm going to cancel the a with the a, and then the a plus 1 with the a plus 1. Yes. You can do those individually because they're being multiplied.
Okay.
You're welcome. All right, 2 more examples and then we'll get to start our homework. Everybody good on 7 and 8? Okay, let's try the next one. Number 9. Again, I've got all 4 operations going on. I've got subtraction in the numerator, addition in the denominator, and then again, the main fraction bar is division, and then I'll do my state change flip. So I'm going to do the numerator first, and I'm doing 2 over 1 minus 2 over x. My common denominator is x. So I need to multiply the top and the bottom by an x. So this becomes a 2x.
Don't you change it to plus a negative 2? Or when do you do that? Like when
you can
when
do
it's
that.
a subtraction problem?
Let's do that. Let's do our keep change flip here also and make this a negative 2. So then now what we get here is 2x plus negative 2, so I can just make it 2x minus 2 over x. So whenever it's a subtraction, I would probably automatically, before you even try to find a common denominator, do the keep flip change. It definitely helps you, especially if you have more than one term. All right, the denominator, 2 over 1 plus 2 over x, common denominator of an x. This one's missing x, so 2x. So this denominator becomes 2x plus 2 over x. So now I have 2x plus 2 over x. So now let me go ahead and set up my division problem. I'm doing 2x minus 2 over x divided by 2x plus 2 over x. Keep change flip. Minus 2 over x times x over 2x plus 2. Next, I need to look for things to factor. I could actually factor a GCF of 2 out of this one and this one. So now I'm left with 2x minus 1 over x times x over 2x plus 1. I'm going to look for things to simplify. The x's simplify, and so do the 2's. And now I'm left with x minus 1 over x plus 1. Again, nothing cancels because, again, they're attached. One last example. All I have to do is subtract the numerator, and then I divide. So my numerator is 1 over x plus 3 minus 1 over x. We could do our keep flip change here, make this a -1. So now my common denominator again is going to be both. It's the x times the x plus 3. Remember, you can't just add a +3 to the second fraction. Finding a common denominator involves multiplication. So my first fraction is missing the x. So this becomes an x in the top. And then I have a -1 here. Actually, let me just leave it. I'm going to put it over here. So this one's missing the x plus 3.
Wait, you don't make it x squared plus 3x in the denominator?
No, leave it factored. Because when you finally finish dividing, you remember you want to look for things to cancel. So you don't want to distribute the denominator because, again, we're looking for things to cancel when we divide.
Right.
All right, so I'm going to distribute the -1 to the x and to the 3. Do this so you can see it better. -x minus 3. I now need to add my numerator. So x plus -x is 0, and then I'm just left with -3 over x times x plus 3. So that's my new top. So it's at -3 over x times x plus 3, and then the denominator is just the 1 over x. Now I'm going to turn it into a division problem. I'm going to go down here. So it's -3 over x times x plus 3 divided by 1 over x. And I'm going to come down here so I can write it in a darker color. So now I have -3, stay, change, flip. Only thing that simplifies are the x's. So final answer here is -3 over x plus 3. The 3's cannot be simplified. And if you forgot to do the keep flip change at the beginning, chances are you would end up with a +3 in that numerator and you'd get it wrong. And again, if that were a multiple choice question, chances are you would get it wrong because you forgot to do the keep flip change at the beginning. Any questions? All right, so we actually have, let's see, we are here until 55, so we still have time here. It's only 41, so you guys have about 14 minutes to work on your homework. So what I want you to do is go to Canvas, open up the homework. It's P5d, and it's due tomorrow.